Hello friend and welcome. In this video, let's play with the coolest programming language, Haskell. Okay, and let's get started. So this is my terminal, right? This is my terminal. We're using GHCI, Haskell, Haskell compiler interactive. Okay, so GHCI, yeah. The Prelude, right? Prelude is the standard library. Yeah, in this GHCI environment, Haskell provided some default functions inside this standard prelude. Okay, so yeah, what if I want to change this prompt, like, so I can do set prompt like this, right? I like lambda, this guy, and a colon. Okay, cool. So let's review some let's introduce some built-in functions. For example, add. Is there an add? Let's see. Type add. There's no add. Okay, cool. So there's a yeah, add is actually this guy, right? Add is actually this guy. Okay, so we can do function call like 3 and 5, 8, right? So there's for a function with two parameters or two arguments, we can do either way. This one, infix, right? The operator is in the middle, or the prefix. We need to put the parentheses around it, like 3 and 5. Same thing for the minus sign, right? 3 minus 5 is that, or minus function call, right? 3 and 5, same thing. And what else? What about one thing is interesting. If you do like 6 divided by 3, this is not for integer. This division is for fraction, decimal numbers. You see, what is the one used in for integers is div. So it's like that. Div 6 and 3, we get 2. So how can we put it in the middle? Infix 6 tilde. Okay, so tilde and div tilde 3. Okay, so we can define our own add function, right? Define the function like add x and y equals add plus y, like that. So we can do add like 7 and 13. We got that. This is our own, right? This is our own function. So how can we use the infixed form? 7 tilde add, any function with two arguments, we can put it in the middle like that. So another system function is modulo. It's the remainder thing, right? For example, okay, let's check its type. Mod integral, it means for the any integral type, like you can think of this like two parameters or arguments and return an integer, right? Or later on you understand that this is like a curried function, so it means with one input it returns a function which accepts one argument and return an integer. Okay, but anyway, don't worry too much about that. We'll get used to it down the road. For now, we only need to know mod like 13 5. What is that? 13 divided by 5, right? The quotient is 2 and the remainder is 3, right? Yeah, 3. Or we can use this way, right? tilde mod 5 3. Yeah, that's because we'll use this guy in our later examples, so that's to another. Oh, okay, so how can we check, right? If a number is like is even, we can use, for example, let's check, is this one even or not? We can use that, right? Mod 2 equals 0. It should return true. Yeah. Now what about, okay, you can use up arrow key to go through the history. So 19 false, right? Very good. Now let's do our meat business. What do we want to do? This one. So we'll try the factorial. Let's define the function for that using recursion, right? Recursion in Haskell is like ABC, is the normal thing, right? And you'll see it's very cool. It's very cool to write very short Haskell code to do some amazing things. Okay, a single line of code can implement factorial. So factorial, how can we define that? Like n equals what? So we know, right? To create a recursive function, we need an ending, like base case ending condition and a recursive code, right? So ending one, if n is 1, right? Then that's the if then thing else in Haskell. Then it's 1, right? Else, if it's not 1, is n times factorial what? N minus 1. That's it. That's all the code. It's so pure and elegant. Factorial n, right? That's the definition. This is the function name. This is the argument. After the equal sign is the definition of the function. If n is 1, then of course factorial n 1 is 1. Else is n times factorial. Okay, let's give it a try. Factorial, we know, right? We know 5 is 120, and we know 6 is 720. Yes. And what about 3 is 6, right? So we can do this factorial 3. What is that? So this part is 6. Then factorial 6 is, yeah. Now let's do greatest common divisor. Okay, And because the system already has this one, GCD, you see? So let's give it a try. The system one is like that. Yeah, right? The greatest common divisor of 24 and 15 is 3. Now, in our previous video, we introduced the algorithm of GCD, but now let me repeat it. Okay, so text edit. Let's open that so we can talk about the algorithm here. Oh yeah, so the algorithm is, right, I think it's called the Euclidean algorithm. So starting from something like that, then we put 15 here, the next step. And what's the next? Here we put this guy mod 15. So what is that? Is 9, right? 9. The remainder of 24 divided by 15. Yeah. So keep going, put a 9 here. This is the previous, right, step. We put the second number as the first in the current row step. So what is here? 15 modulo 9, right? So this number is guaranteed smaller than this guy, right? Because it's the remainder. The range of this one is 0 to 8. Okay, so now what is this? This is 6, right? So next step, 6 here. What's the remainder of 9 divided by 6? 3, right? Okay, next one, 3. Now the remainder is 0. Okay, and so this is the GCD, greatest common divisor. Okay, now let's apply this in our single liner in Haskell. Okay, so we can use this name, right? Prime. This is different, so let's check. There's no such thing, right? GCD prime. Okay, so now we can define GCD prime, our own GCD implementation equal, oh no, m n, right? With 2 parameters, 2 arguments, equals if n, right, the second one is 0, then we return the GCD is m, right? The ending, the base case, the ending condition. Else, oh sorry, else we'll call GCD prime, right? Call itself. Now what? Yeah, in Haskell, the function call that we don't need parentheses. Yeah, it's so pure and beautiful. GCD now, the n is the first number, right? And the second one is mod what? M n, right? Is that okay? Let's try. Okay, so we need some parentheses. GCD. Oh, I think this part we need. Yeah. Otherwise, yeah. So this part, so GCD 2 numbers. Let's see. Okay, now it compiles, right? GCD prime 24 and 15. Ta-da! Okay, what about this one? 24. Same thing. Why this also works? Let's check here. Okay, so what if we switch the two things here? Now, what is the next one? We put 24 here, right? So what is 15 mod 24? 15 divided by 24. The quotient is 0 and remainder is 15. So you see, it turns back to this scenario. Amazing, right? So I can use dot 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 because they are saying just you will go through this and eventually we have 3. Okay, now let's try another one. GCD like this one and that one. We know the answer is 8. Okay, that's it for today. See you next time. Thank you for watching.